Brian Maestri, continuing with the assessment of flood risk using the HEC-FDA model for coastal evaluations, and the case study being Southwest Coastal. And in this portion, we're going to look at the inputs and the calculation of uncertainty using the HEC-FDA model, but we're going to specifically look at the uncertainty surrounding first floor elevation of residential and non-residential structures. If you go to Chapter 9 of the HEC-FDA manual, you see a simple table, Table 9.1. It talks about uncertainty based on measurement methods. If you remember in our intro, we talked about uncertainty being based on the method that you use to calculate whatever the value is for a parameter, in this case being the first floor elevation. Well, at the beginning of the Southwest Coastal study, we actually did use 2-foot contours. I know today LiDAR information would be using. And with the 2-foot contours, you can see in the table using the aerial survey, it says the error associated with a 2-foot contour is plus or minus 0.59 feet. And then in the fourth column, they had the standard deviation is 0.3. So how did they get from the error being plus or minus 0.59 feet to 0.3 feet standard deviation? We're going to look at that. And then also, hand levels, we use it for foundation heights. For the foundation height, the error using a hand level from 50 feet away is plus or minus 0.2 feet. And it has a standard deviation of 0.1 feet. And so we're going to look at how it gets from the error to the standard deviation, because this is what we incorporate as our uncertainty in our HEC-FDA model for first floor elevation. So this slide shows that there's a whole bunch of assumptions beyond that go into that. It assumes a normal distribution. For a normal distribution, the mean, the central tendency is a mean of 0 with a standard deviation of 1. So if we look at the ground elevation, there's a statistical formula that talks about the z-value that you can get from a statistics book. The z-value is related to a level of confidence. And I learned that for most core studies, it's the 95% level of confidence that we use. And that's equal to the error minus the mean divided by the standard deviation. Well, the z-value we can get from a statistic book for a 95% level of confidence. It's 1.96. What is our error for ground elevation? Well, if you're using 2-foot contours, we just saw in the previous slide, it is plus or minus 0.59. So that goes into the error. And then the mean, we know normal distribution is minus 0, and the standard deviation is 1, or just we're solving for the standard deviation for the ground elevation uncertainty. So we got 2, and we're missing 1 variable, so we can do a little algebra and get to the answer. And if you notice, the 1.96 is equal to 0.95 divided by the standard deviation. We bring the standard deviation to the other side, and we get 0.59 divided by 1.96, and you get standard deviation is 0.3, which is what exactly was in that table. So that's how you get from the error to the standard deviation. For the foundation height, same formula is used, 95% level of confidence, 1.96, and the error associated with that is plus or minus 0.2 feet. So we plug that into the error, minus the mean, a normal distribution, 0, and we're solving for the standard deviation. It's divided by the standard deviation. So now we got 2 known values, 1 unknown, so we can solve for that one. And the standard deviation is equal to 0.2 divided by 1.96, and that's equal to 0.1. Can't go back to the previous slide when we're recording, but if you go back, you can see that that's exactly what they had in the table. So I know the HEC-FDA users manual doesn't explain all that it's assuming a 95% level of confidence, it's assuming a normal distribution, but that's how it gets those values. And a normal distribution, by the way, is, as you can see, it has an equal amount on the right side and on the left side. So that for 95%, 0.475 is on the right side and 0.475 is on the left side. So it's symmetrical is what we would say. Going to the next slide, though, we're not finished because we got 2 uncertainties. We got standard deviation for the ground elevation and a standard deviation for the foundation height. And in statistics, you just can't add those two up. There's a formula for that to get the overall standard deviation. That's equal to the square root of the sum of those squares for each of those. And that formula shows the first floor elevation uncertainty is 0.316. And that is what we would enter into the HEC model for the uncertainty surrounding the residential and non-residential structures if you used a 2-foot contour and a hand level from 50 feet. If you use LIDAR, there'll be a different error associated with that, and you just plug it into this formula, and then the error that you calculate associated with your foundation height, you'll get a standard deviation with that. Put it here, and you can add them up and enter that into the model. So risk assessment cost, of course, and we just show how you calculate the uncertainty surrounding your first floor elevation.